Good afternoon, dear students. Our top
Hello.
hello, hello. Uh,
Good
Good
afternoon.
afternoon, everyone. Yeah, so our topic for today is systems of linear algebraic equations, and today we will use our knowledge from previous lessons, such as determinants evaluation and operations with matrices. And the first question, what do you know about uh, Cramer's method for solving systems? What do you remember about it? Who wants to answer the first? Matvey, go on.
Well, as I remember, we have a system of unknowns for Cramer's rule, and we use determinants. Um, well, if a determinant doesn't equal to zero, then the system has unique solution. Um, and we need to replace a column J with some vector.
Which vector?
A vector B. And we use the formula xj equals determinant that is changed and we
Divide.
divide it by first determinant that is not changed.
Correct, yeah. So we find determinant for matrix of our system and sequentially replace each column with the vector of free coefficient. And yeah, good. So important option. Good note is that the determinant of the system must not be equal to zero. It means that the system has solutions. Correct. Okay. So let's start working with let's start solving a system of equations with Cramer's method. I will share my screen, so we will solve the example. It's lagging a little bit. So firstly, let's evaluate the determinant for the matrix of system. Let's make it a bit thicker. Let's name it. Let's mark it as delta. Like one of the ways how to mark determinants. So different symbols. Okay, and who wants to assist? Someone new? Vadim, go on.
Yep. we multiply 5 on 1 on 7 and get 35. Then we multiply 3 minus 3 minus 5 and 1 and get plus 15.
Mhm.
And multiply 3 on minus 2 on 1 and get minus 6.
Yes.
After that, I usually write like a minus and then скобки, braces,
Brackets, yeah.
brackets.
Good idea.
So here we get 1 1 1, it will be 1. 3 minus 3 is 7, it will be minus 63.
Mhm.
And minus 2 on minus 5 on 5 will be 50. Plus 50.
Yeah, plus 50. Okay. So
You open the brackets and get 50 minus 6 minus 1 plus 63 plus 50.
so before these brackets actually we
Yeah, we'll
44.
have 44. Yeah,
Yeah, minus
1 plus 63 and minus 50.
yeah,
It will be minus 13, minus 12, plus 12. How was it?
yeah, 44 plus 12, 56. Okay.
Yep.
And who wants to be the next? If I'm not mistaken, Dmitro raised the hand. And which determinant do we have to calculate now? How it will change? Oh, by the way, yeah, so we have everything what we need, all conditions. So Dmitro, go on. How this determinant is changed if we look at this one, delta without indexes. Or maybe anyone else. It was a mistake. Okay, so David was raising the hand. Yeah, the previous.
Yes, as I
Okay,
remember, we
okay, your turn.
changed the first column with 2, 4, and 3.
Yeah.
So now we get 2 minus 3, 1.
Okay, let's just replace this row,
Or like that, yes, and
column, and
anything else
yeah,
doesn't change.
yeah, we'll just copy and paste it.
Yes, yes.
Save our time. And now let's calculate. So,
So we multiply 2, 1, and 7, it will be 14.
mhm.
Plus minus 3 multiply with minus 5 and 3, it would be 35.
35. Mm,
So we,
maybe 45.
oh, I said yes, 45, I mean, yes.
Yeah,
And we multiply 4 with minus 2 and 1, it would be minus 8.
yeah, and let's
Then let's put braces.
brackets.
Braces, yeah. And we multiply 1 by 1 and 3, it would be 3.
Mm-hmm.
We multiply minus 3, minus 3, minus 5, and 3. It would be minus 45.
3 and minus ah uh, minus which no it's a mistake. So this one, yeah, we have, you mean
So
this triangle, or which of them? Correct?
Yes, sorry. We multiply 4 with minus 3 and 7. It would be 80 minus 84.
Mhm.
And the rest are
Mm. Do everyone hear David, or maybe problems on my side?
Do not
Sorry?
hear.
Mhm. Okay, so
Do you hear me now?
yeah. And I will better stop the video.
And now we use minus 2, minus 5, and 2. It would be 20.
Yeah, 20.
And now 14 plus 45, it would be 59. Minus 10, it would be, yes, 51. And
Yeah.
and minus so it would be 3 minus 104, and it would be 101.
Okay, let's just make a plus.
It would be, yes, plus, it would be 152.
It seems that we have a mistake here, because actually it should be divided by 56. So let's
There is a minus,
sorry.
so
I'm sorry, the mistake is was 20. This is plus 20.
yeah. So just here we have a mistake, and now let's recalculate it.
it would be 3 minus 64, it would be minus 61.
Yeah. So actually plus 61 here.
61, and it would be 111.
112.
12,
Yeah, so
sorry.
it will be divided in a beautiful way. So I remember that convenient calculations. So like any exercises. Okay, so who want to be the next? Sophia?
Now we need to change the second column by the constant vector, and it will be 5, 3, 1. Oh, here, yeah.
Yeah,
3, 4,
let's just
3.
let's do it in a quicker way. So just it's good that you remember that we need to. So which column must be replaced? And let's move this 3 here. Okay, and now let's calculate.
So it will be 5 by 4 by 7, 140. Then plus 9, minus 10, minus 4, then plus 75. Oh, if we're doing it with the brackets, so it will be a plus 75.
No, so in brackets minus 7.
Minus.
Yeah.
Minus.
So just not to get confused, but it seems to be
I'm just
as well.
Yeah, I'm writing it without brackets. Then Then it will be 42.
Yeah, 42.
And if we calculate it, it will be
Okay. Help you.
18.
Mm. Do you mean
Oh no,
mm,
it wouldn't be 18.
yeah, so let's first this part and this part. So here we have 139 and here so minus but not minus, it will be a plus plus 30
29.
No. So minus so what we have 46 minus 75, it will be minus 31. And that's actually not correct. So let's search
Minus
mistake.
29.
Minus 29, but we'll have 110, and that's not correct as well. So no, here is everything correct, and so the determinant itself is correct. $140, yeah. Minus 10 plus 9, so correct. 4 minus 75 plus 42. So something doing incorrectly, but let's recalculate it now in a quicker way. So, yeah, correct. It was so plus 92, yeah. So we have 180 or 68. My bad. So I need to have a rest today. Okay. And who will be the next? Vitaly?
May I? May I? I want to try.
Okay, so decide
So-
yourself who wants to be. So the priority is for new people. So who wants?
May I?
Vitaly, yeah? Okay.
Yeah, I think I figured it out. So we swap out the third column numbers with numbers 2, 4, 3.
Mm-hmm. 2, 4, 3.
And leave the rest intact as they are.
Yeah, so without changes here. And let's move it. Continue moving. And this a little bit left.
Oh. All right.
All right, yeah. It's
So
good that currently I'm not driving.
now, so it's 15. Minus 8. Which one do we start with? The low one or the upper one?
15 minus
Depends on which one we start. the upper one, then it's -9.
So the first we calculate this, so the main diagonal and these triangles. So we need to calculate this. But let me
Right.
say it with
Sorry.
zoom.
Sorry. So it'll be -12 then.
Mhm.
No,
Yeah, and -12 actually. Yeah. -12, -12.
12, yeah.
And
And in brackets, we have 2, first of all. Then we have a -40 one of
Mhm.
them.
-40.
And we have -27.
And -27, yes.
Right. So now
-1.
So 15 -12 it's gonna be
Here is -65 plus 65 is
it's
56.
9. Yeah, I
Okay.
suppose this.
And now who will assist me in finding the solution? Yeah, Pavlo, go on. So the final solution.
To find x, we need determinant 1 to divide on determinant. 112 divides 56.
Yeah, so we'll write
It
in detail.
it will be
So
it will be 2.
yeah, it will be 2. And the next.
Next
Okay, let's
y.
Oh, y, yeah, so
Y. We
yeah.
need determinant to divide determinant, and it will be 3.
Yes. And that.
That determinant 3 divide determinant, it's 1.
Yeah. So, but let's write it in details and then the final result. Okay, and now let's verify that the result is correct. So what we do, we just check ourselves. So multiply 5 by 2 minus 3 by 3. Okay, I will do it in my own currently. Plus 1. So 10 minus 9 plus 1 is 2. So the first equation is correct. Then 3 by 2 plus 3 minus 5. So 6 plus, so 9 minus 5 were 4. So the second equation is correct. So, 2 minus 2 by 3 plus 7. So 9 minus 6 is 3. So the solution is correct, verified, and yeah, so actually the same as in our example. Here it's so here only the first equation verified, but spend your time to check all of them. So just a couple of minutes, but it will save you time if you see the mistake, and you will just solve it again, and just you will be sure that all is correct. Okay. Here we have as well the example with the grammar method, but now we'll skip it. It will be like your home task, but maybe if we have some time, we will solve it, or maybe other example. What is interesting for us now? Yeah, what do you remember about using matrix method? Who wants to answer? Raise your hand. Who wants?
To calculate
Yeah.
example 3,
So, so using matrix method, how do we use it? How do we solve?
You mean inverse matrix method?
Yeah, actually, we call it matrix method, inverse matrix method, so different namings. Yeah. So, Alexandra, can you answer?
can I answer about example 3? I can start solve it.
Maybe you can explain in general way. How do we do it? So, actually, yeah.
I get numbers from range 1. These numbers near x. Show me, please.
Actually,
Example.
so
Show me, please.
I want to just hear general method. So we have a metric
Okay.
in such form. So ax equals b. So matrix form of equations. So this is the matrix of the coefficient. X is the vector of variables, and b is vector of free coefficients. And how can we find x? So we need to get x on the left side of this matrix equation. How can we do it? So, Alexandra, any ideas? Just a general way.
I will solve it like in first task.
No,
What
we have
we
to solve
did.
using matrix
What
method.
we did.
We have to use matrix method, not Cramer's formula. So,
Yes.
or inverse matrix method. So how to get x on this side, only x.
Inverse matrix A.
Okay,
Multiply.
Sophia, please raise your hand. Yeah, but I see that Bogdan hasn't answered yet. So
I'm sorry.
Bogdan, your turn. Yeah, so the priority.
Yes, Sophia already said that we have to multiply each side with the inverse matrix of A.
Yeah, but and on which side actually do we have to multiply?
Both.
No,
Left and right.
so from the left or from
Because-
the right?
From the left.
Yeah, so multiply from the left. Yeah, so we need to multiply all sides, and it's important actually. But we can't multiply. We cannot multiply b by inverse a from the right side because of their dimensions. So this part will be eliminated, so not eliminated, but will be simplified. It will be equal to E, so identity matrix. And actually, the final result is so how finally to get the solution is to multiply vector of free coefficients by the inverse matrix. So, Alexandra, did you understand the idea?
Yes, I get it.
Yeah,
Danke.
so just a general way. So I was not asking about how to find the inverse matrix, but just how to use it. By the way, again, a question for you. In which cases this method can be used? So for any system or not? Maybe there are some cases where we can't find the inverse matrix. Question for Alexander. So, any ideas? Do you remember?
Oh, what? I feel so bad now.
Or maybe you should just yeah, take a, like a sick leave and then review the lesson. But okay, so just how you feel, but get well soon. So, Andrei, your turn.
If determinant is 0,
Mhm.
we can't use this method.
Yeah, so we need to verify that the determinant of A mustn't be equal to 0. So only if this condition is correct. So only in this case. Okay, and now let's solve the example. So firstly, let's verify that we can use the matrix method here. Anyway, we will need a determinant, so let's calculate it. Oh, it's overlapping. Okay, let me move it a little bit right. So, who wants to calculate the determinant of A? New people, please. Dmitro.
Так. Перший 3, 1, 2. 2, 1.
Yeah, let's now in row by row.
1, мінус 1, 2.
Uh,
Oh yeah, I forgot what you were supposed to do.
yeah,
in
better
English.
English.
Yeah. 2 minus 1 plus 3.
Yeah, 2 minus 1, 3. Okay, and let's calculate.
So the first one will be minus 9.
Mm-hmm.
Then minus 4.
Minus 2, 2, maybe you
Oh,
wrote
minus
something.
8.
Minus 8. And minus 1.
Minus 1. Mhm.
Okay.
So 2.
Okay, let's write now. So
Oh,
minus
yes, because we have, yes.
here, outside of brackets.
Okay. Minus 1 times it's minus 6, but it's plus 6 because we have brackets.
Okay, let's leave it here for now.
Okay.
Minus 6 and actually
yeah.
minus 6 as well.
Yes. It's minus 18.
Minus 18 plus 14.
It's minus 4.
Yeah, minus 4. And it's not equal to 0. So we can use the matrix method for current system. Okay, and now let's find inverse matrix. So who wants to assist? But by the way, how are you going to find it? So which actually which methods of inverse matrix you know? So who is new? Who wants to answer? So some new people, maybe Alisa? Do you remember how to find the inverse matrix?
Yes, so we need to change симметрично. Симметрично.
You
Относительно
mean
диагонали.
transpose, yeah?
Yes.
So firstly we transpose the matrix A, and so what does it mean actually to transpose? So Alisa, go on.
First row will be a 3, 1, and 2.
3, 1, 2. Yeah, so we just change columns and rows. Yeah,
Yes.
then
2 minus 1 and 3. In the first row it's minus 1, 2.
Yeah, so we just make it a row and
просто
this and this. Yeah, so -2, -1, -1. So it will become a row, and this, yeah, actually, so what remains? So
1.
So 1, 2, 3. So each column became a row, or vice versa. So it was a row, 3 minus 2, 1, and here it is a column. So we just change columns and rows, and just remember that we can transpose any matrix. It doesn't matter if it is square or not. Okay, and what we do next when we transpose the matrix?
Now we need to find cofactor, I think it's named.
Yeah, cofactors. Oh,
It will be first one.
I will. Okay, yeah. Let's do it actually with. Don't forget the t sign. So yeah, -1 in which power?
2.
Power of 2. Yeah, and which numbers do we have here?
-1, -1, 2, and 3.
And here -3 plus 2, it equals -1. And it is just 1. Okay, let's.
I'm sorry, Pavlo got some technical problems, and he will return as soon as possible.
Okay, so anyway, he will have the ability to review and ask, and feel free to ask questions. So it is related to everyone actually. Yeah. So Alisa, let's find 2 more cofactors, and then someone else will continue.
It's -1 multiplied by
So this one.
matrix.
So -1 power of
3.
Power of 3, and which
-2, -1, 1, and 2.
yeah, -2, -1, 1, 3. So -6 plus 1. So actually it's 5. Yeah, let's turn it to the plus. And A1, 3. Let's evaluate it.
It will be -1 in power 4 multiplied by matrix -2 -1 1 2.
Yeah, this determinant. Yeah, and a power of 4, by the way. So -4 plus 1 is -3. Okay, so next, Katerina. Okay, how do you prefer?
Well, 821 transposed equals -1 in power 3. The determinant of first column 1 2. No, column.
Column.
Not row.
Yeah.
Yes, 1 2.
But actually the row will be the same.
Yes, yes. 2 3.
Yeah, and here we have minus, so
3 minus
3
4.
minus 4, actually -1, and let's just turn it to plus. Both plus.
Mhm. -1 power 4. The first row 3 1. The second row 1 2.
The row 3 2. Actually, yeah. So if the row, but the column is 3 1.
Mm-hmm. I understood.
Yeah, 9 minus 2.
9 minus 2 7.
Okay, if I little bit zoom out, do you see? Do everyone see well?
Yes.
Yes, yes.
Okay, and let's calculate one more, and then someone will continue. So -1 power of
5.
5, yeah.
And 3 1 1 2.
3 1 1 2.
6 minus 1.
Yeah, so
Minus in bracket 6 minus 1.
okay,
Minus 1.
just -5. Well, let's write it shorter.
-5.
Yeah,
Yes.
it's -5. Okay, and who wants to be the next? Thanks, Kate.
Can I choose?
Vladimir, yeah, go on. So go on. Vladimir. So we don't hear you.
Now?
Yeah, currently here.
That will be -1 in the power of 4.
Mm-hmm.
And in determinant, it will be first column 1 minus 1.
Mm-hmm.
And second column is 2 minus 1.
2 minus 1. So -1 plus 2 is 1.
Yeah.
Okay.
Next, a transformed 3 2.
I need to zoom out once more.
Yeah. And that will be -1 in the power of 5.
Yeah, -1 in power of 5. And
determinant will be first column 3 minus 2.
Mm-hmm.
and second 2 1.
Two minus 1.
Yeah.
Don't lose. So 3 minus 2, 2 minus 1.
That will be
So minus 3
minus 3 minus plus 4.
So just minus 1.
Yeah.
Let's leave in such way.
3 is 3. Minus 1 in the power of 6.
And
first column is 3 minus 2. And second 1 minus 1.
Yeah, I will just do in this way. Oh. More accurately.
That will be minus 3 plus 2.
And it's minus 1. Okay, so the matrix A will will have the next form. So actually, could you name so how will it look like the matrix A minus 1? So let's write it with the results so that we have.
First column is minus 1, minus 5.
Plus 5.
Oh, plus 5, plus 5. And minus 3. Then 1, 7, and minus 5. And then 1, minus 1, minus 1.
And what else we need to do here? What is missing? It's not the final view of inverse matrix. So maybe someone, a new person, Bogdan, if I'm not mistaken, you are new for today. So
You also need to multiply it by fraction of 1 over determinant of A, so it will be 1 divided by minus 4.
yeah, correct. So it is the final view of inverse matrix. Okay, and now let's solve this system. So we just need to multiply by this column. 1 minus 3 minus 4. And the result will be the vector. Yeah, let's check. Yes, so everything is correct with the signs. So let's leave the determinant for now, and now just calculate the vector, and then we will divide by minus 4. So who wants to assist? Alexandra, yeah?
Yeah, it's me.
I know, so go on.
For begin, I will to get range from first matrix and обернути другу матрицю.
Oh. Now, Alexander, we have already inverse matrix. I remember, yeah, that you feel sick, so maybe currently you can skip. So just as you want. Yeah, I see that
Sorry.
that something is not correct. So maybe anyone else? So actually, there are a lot of people who hasn't answered yet. Valeria, do you want to answer? So,
Well, yeah.
sorry?
First row will be the first row will be -1 plus -15.
Okay, minus.
Excuse me, I have a question. Where did we get 1 divided by 4?
Okay. So actually, we need to divide by determinant. So this matrix of cofactors. So
Okay, thank you.
maybe anyone has questions? No? Yeah, be attentive, don't use determinants because it will impact, so it will cause errors, mistakes in your solutions. Yeah, so Valeria, go on, or maybe David, you have questions?
No,
So, okay.
wanted to answer.
So the first priority for new people. So Valeria, continue.
-1 -15 plus 12.
Plus 12, yeah. So
The
the
second
next.
row 1 -21 and plus 20. There we go. Plus 3 -4.
1 plus 3 minus 4. Yeah, and what do we actually have? So minus 1/4. And here we have minus 4. Here just zeros. And the result is just 1, 0, 0. Like identity vector. Okay, and now let's verify the result. So it will be a good manner for you. So 3. No, something is incorrect. Something is incorrect. Let's check just first the inverse matrix, how it looks like. Yeah, so incorrect calculations. So some mistakes here. So 1 plus 3 plus 4. Yeah, so 8. And here is 2. And nobody told me. Nobody raised the hand. But
Plus 4.
sorry?
And why is it plus 4?
Yeah,
So,
it should be -2.
yeah, -2. Yeah, no, thanks for your attention. So 1 plus 3 -4. Yeah, so something is incorrect. So Yeah, because here we have -1. And now everything is correct. So just a mistake here was lost minus. Okay, so now continue verification. So 3 minus 2 is 1. Oh, correct. Now 1 minus 4 is -3. And 2 minus 6 is -4. So finally, we have correct result. So just now you just see that we really need to verify our result to check ourselves that everything is correct. Maybe you have some questions for now or not. So any questions about matrix method? Or maybe some questions appeared about Cramer's method.
No.
No at all.
Okay, so now let's have a break for 5 minutes, and then we will continue with using Gaussian method. So now just try to remember what you know about that method, but better let's have a break. So tea, coffee, or just some movement activity. let's continue. So now the question is, what do you remember about Gaussian method? So who wants to answer? So new people.
Don't
Who
see
hasn't
your
answered
screen.
yet? Because I'm not sharing now.
Okay, it's supposed to.
Yeah. So just answering, asking a question, who wants to answer? So new people, raise your hands.
Could you repeat the question because I missed it?
But you have answered before, so the question is about Gaussian method, so how it used. But I want everyone to take part. So maybe Herman, you are the new student
Yes.
for today.
Yes, we form a matrix out of the coefficients of unknowns. And we can also form augmented matrix by adding a row of constants. Then we transform this matrix into upper triangular and solve the equations that we get.
Yeah, so we just need to eliminate, so we need to transform matrix to the triangular form. What we already were doing on previous lessons to simplify determinant calculation, or to define the rank, or maybe to inverse matrix. So elementary transforms. And actually, the Gaussian method or Gaussian elimination method actually means so uses the same idea. So we will have to get zeros here. So and then we will calculate, we will find the solution. By the way, you actually used such method in the school, but just without knowing it. So like system of two equations, so like in such form, and identically, so A2 with by x, b2 by y, and so what did you do? Firstly, you eliminated either x or y, and then it was easy to find both variables. So the same idea, but more equations. Now let's delete it. Just not to be afraid of something new. It is not new for you. Okay, and what we actually do, I won't write it from the scratch. So it is the extended matrix of our system. Yeah, let's copy and paste both matrix, both the system and the matrix form of this system. So it is the extended matrix. So on the left side we have coefficients for our variables, and this column that extends the matrix is just a column of free coefficients. Now, why do we need such a view? Just yeah, so because we need to transform both sides of the matrix. What I want to do the first. First, let's swap two. So let's swap this row with this one. So the second with the first. Why? Because we have one before x, and it will be convenient for our calculations. So without skipping any steps. And now I will have to get zeros here. So the first row is without any changes, but the second and the third will be modified. So here zeros, and how to eliminate them. Who will assist me? What should we multiply? What should we add? So new people. Maybe Lilia. By the way, are you online? Yeah, so Lilia, go on. I don't hear you if you are talking.
I just need a second to think.
Okay, not a problem. By the way, here we just swap these equations, and nothing changes, so the matrix is equivalent, and the solution won't change. So it doesn't matter which order. So how to eliminate the third row, or the second row? Do you remember elementary transformations? Oh, you need some more time. Oh, let's start solving together. So here I have a 0 and how to achieve it. I have to multiply the first row by 3 and then subtract it from the second row. So do you understand the idea?
Yes.
So that's just how we have 0 here. So what do we have here? So we multiply.
-3.
So we multiply 2 by 3, and then we have to subtract.
-6.
So -2 minus 6, and what we have?
-8.
Yeah, -8. And for this coefficient,
-12.
So I have to multiply it by 3 and then subtract. So be careful with the signs.
6.
Yeah, 6. So we multiply by 3, we have -9, and we subtract, so we add 9. So 9 minus 3 is 6. And here,
-2.
-2, yeah. So let's have more practice. Let's calculate this row as well.
-5.
Yeah, -5. And here,
5.
yeah, 5. And here,
0.
0. Correct. Okay, so currently, do you understand the idea of Gaussian method? So the elimination and elementary transforms in general. So currently, did it become easier for you, or maybe you need more practice?
I think I understand it.
Okay. By the way, I have a question also for you. Maybe you have an idea how to simplify this system. So just this row and this row. Any ideas? To simplify our calculations for the future.
We can extract -2 from the second row.
So do you mean to divide, right?
Yes.
Yeah, and this row?
Divide by 5.
Better even by -5. But for now, let's just go with the next. So the next way. So currently, just divide by 2, and then we will see if we need to divide. So if we need to change sign or not. So here we will leave -4, 3, and -1. So yeah, we can just divide the whole row. So it just means that you divided both left side of equation and the right side of equation. And here the same. We just divide this part of equation by -5 and this part of equation by -5. And nothing changes. Okay. So it seems that you understand the material. Okay, and now let's do the following. I want to swap these rows, the second and the third, just for convenience. I will write everything in details just for better understanding. So here 1, -1, 0. And here we will leave -4 because anyway we will eliminate it. Okay, and now let's continue transforming matrix to the triangular form.
Excuse me, I haven't heard. What have we done? Well, after the fourth matrix, we divided it by 2, right? And then
You mean this matrix, right?
no, the high one and like left one.
This
1, 1, 2, -3, 0. No. On the higher row, fourth one.
This one, right?
No, the left one.
So
we divided it by 2.
So we divided by okay, let's make clear everything. So we divided this row by 2 and this row by -5. So we just divide two sides of equations. So this is this part is divided by 5 and this part is divided by 5 and by -5. So and the same for it. So actually nothing extraordinary, nothing new to you, but in matrix form. Yeah, by the way, matrix is a little bit new. So any questions?
No, thank you.
Okay. Okay, and now who will assist me in our final steps here? So someone new. If I'm not mistaken, only Maxim left. So Maxim, go on.
We get 7.
Uh,
No, we multiply second row
Mhm.
by 4, and we get 7, and
Stop. We multiply here by -4 and we subtract it. So we multiply this by -4 and we have 4 and we subtract, so we have -1. So attention. And here we have just -1 because nothing changes. Okay, so it was the forward Gaussian elimination. And now we will do the inverse Gaussian elimination, how our system currently looks like. So x1 plus 2x2 minus 3x3 equals 1. And here x2 minus x3 equals 0. And minus x3 equals 1. Oh, -1. Yeah, the minus, and how to solve it? We just go from the bottom to the top. What currently we do? So we already know that x3 is 1. Here, too easy. So x2 just equals x3, and it equals 1 as well. And here, how to get x1? So 1 minus 2x2 plus 2 plus 3x3. And it equals, so 4 minus 2, 2. So it is the solution. Now let's verify. So 6 minus 1, or minus 2 minus 3 is 1. 2 plus 2 minus 3 equals 1. 4 minus 1 equals 2. So everything is correct. Maybe you have any questions about Gaussian method? or about previous methods that we saw before?
No question.
No questions. Okay, now we'll just take a look at one more example because we have not a lot of time. But the main tasks we already solved. So we have to solve a system of linear equations with the Gaussian method as well. But here, as you can see, we have 4 variables, but only 3 equations. Yeah, we have sometimes we have such systems, and these systems may have solution or may have no solutions. And they cannot be solved by matrix or Cramer's formulas method, so we can use the Gaussian method. Here is the matrix of our extended system, and after elementary transforms, we get this one. So we have, so we see that these rows of coefficients before variables, they are the same, but 3 members are different. So we eliminate this row of coefficient, and what we actually have that zeros here, so 0x1 plus 0x2 plus 0x3 plus 0x2 equals 9. But it is impossible. So it means that this system has no solutions. So, any questions about that?
No question.
Okay. So for the home task, start doing individual tasks related to the systems of linear algebraic equations, but don't touch for now just the systems which have zeros in the right part, so homogeneous system. We will have it on the next practice. So we'll work with it a lot, and now look at examples that we have in the presentation, and also some exercises at the end. Which exercises at the end? So 1, 2, 3, 4. Okay, for now, just 1 to 3. Oh, even 1 and 2. Yeah, so that's all for now. So check in if you haven't done it yet, and have a nice day. Stay safe. Get well. Who is sick. So goodbye. Thank you for your attention.
Thank you so
Thank
much.
you for the
Have a good
lesson.
day.
Thank you for
Have
the
a nice
lesson.
day.
Have a nice
Bye.
day. Goodbye.
Bye.